Have you ever imagined a world where searching the internet no longer takes you to real websites? Where Google's AI gives you answers directly, but content creators get nothing in return? Meanwhile, Claude, from Anthropic, is quietly evolving into the smartest research agent we've ever seen. This isn't just another AI update. This is the beginning of a fundamental shift in how we access and control knowledge. Today, you'll discover two of the most disruptive AI features released this year, and what they mean for you, whether you're a creator, researcher, or everyday user. So let's dive in before the web as we know it disappears. In this video, we'll break down Claude's brand new autonomous research agent and why it's a game changer, Google's new AI overview mode, and how it might turn the World Wide Web into a wasteland. We'll look at how both tools work, what problems they solve, and what dangers they pose. Let's start with Claude, the silent giant. Claude by Anthropic now features a research assistant mode that acts like an autonomous agent. What does that mean? It can break a complex question into sub-questions, search trusted sources online, read them, analyze them, and return a comprehensive report, all by itself. You ask it one thing, it thinks of 5 more, then brings you the best answers from across the web. This isn't prompt and response anymore. It's reasoning, exploration, and reporting automated. But Claude doesn't stop there. It now integrates directly into Google Workspace. Need help writing a weekly report in Google Docs? Claude can do that. Sorting through messy email threads in Gmail? Done. Looking for a PDF hidden somewhere in your drive? Claude finds it in seconds. Imagine giving your AI access to your workflow and watching it clean up the chaos. That's where this is headed. Here's why this matters. Right now, millions of professionals spend hours per week researching, compiling, writing. Claude's upgrade could eliminate entire layers of manual effort and instead turn every curious mind into a strategist. It's not just about speed. It's about turning raw information into structured insight instantly. But while Claude is helping us think, Google might be stopping us from thinking at all. Google's new AI overview mode, formerly known as Search Generative Experience, is now rolling out globally. What it does is simple and shocking. You search. And instead of giving you a list of websites, Google's AI gives you a full summaries at the top. No links, no sources, no visits to actual content. Just one polished AI-generated answer. Sounds useful, right? But here's the problem. The moment people stop clicking on real links, websites lose traffic, creators lose income, researchers lose visibility, small businesses lose discovery. This isn't hypothetical. This is already happening, and it gets worse. By putting AI-generated answers above all websites, Google becomes the final gatekeeper of knowledge. It decides what's true, what's seen, what matters, and when AI summarizes instead of linking, the open web starts to decay. Some experts call this the AI collapse of the web, and they may be right. So now we stand at a crossroads. Claude, an AI that helps us explore, read, and think. Google, an AI that might replace our need to explore at all. One empowers users, the other risks disempowering creators. Which path should we choose? What do you think? Is Claude's research agent the future of productivity? Is Google's AI overview a helpful tool or a threat to the web? Tell me in the comments. I really want to hear your perspective. And if this video gave you new insights, give it a like, share it with a friend, and subscribe for more weekly breakdowns on the fast-changing world of AI. Until next time, stay smart, stay free, stay curious. Imagine a world where AI doesn't need billions of parameters or massive GPUs to be powerful. Now, imagine that this world is already here. Microsoft just released something that could shake the very foundation of how we think about AI scale and capability. A 14 billion parameter model, beating GPT-4 level reasoning tasks, and it runs locally. Yes, on your laptop, maybe even your smartphone. Let me walk you through why this changes everything, not just for AI researchers, but for all of us. Hi, I'm Francis, and today we're diving into the fascinating world of Phi-4 reasoning models, Microsoft's latest surprise drop in the race for intelligent, efficient AI. In a world obsessed with bigger and bigger language models, GPT-4, Gemini 1.5, Claude Opus, DeepSeek 67B, Microsoft has taken a bold turn in the opposite direction. They've asked, what if smaller can actually be smarter? The result? The Phi-4 family. Let's explore what makes these models so unique and why they're getting attention across the entire AI community. Most state-of-the-art models today rely on hundreds of billions of parameters, often trained with massive compute resources, sometimes for months. But Microsoft decided to focus on something different: careful dataset curation, precision instruction tuning, and designing models to think, not just predict. The 5-4 reasoning model, with just 14 billion parameters, embodies this philosophy. And the results? Well, let's look at the numbers. Here's the first benchmark. 5-4 is compared to some of the most powerful models in the world, including OpenAI's O3 Mini, DeepSeek R1, and even Gemini 1.5 models. Take a close look at AIME 25, a benchmark designed to test pure reasoning. 5-4 Reasoning Plus scores 82.5, beating every other model. Yes, even DeepSeek R1 with 671 billion parameters. In OmniMath, which combines symbolic and numerical problem-solving, 5-4 is nearly tied with O3 Mini, a model widely praised for its math capabilities. And in GPQA, a test of graduate-level multiple-choice QA, 5-4 comes close to the top, beating models many times its size. It's not just competitive, it's dominant. And this is just the beginning. Now let's zoom into the smaller model range, where 5-4 really shines. This chart compares models under 7 billion parameters. The star here is 5-4 Mini Reasoning. In AIME 24, it clearly outperforms other compact models. In Math 500, it reaches 94.1%, placing it nearly on par with models over 12B parameters. And on the GPQA Diamond benchmark, which tests deep conceptual understanding in multiple-choice settings, 5-4 Mini leads the pack. But these numbers don't just reflect raw intelligence. They reflect a model designed to reason, not just memorize patterns. That's a crucial distinction. Next, Microsoft tested 5-4 models across a wide range of tasks, from programming to instruction following, from logic to toxicity filtering. And here's what they found. On Human Evil Plus, 5-4 matches GPT-4 level code generation for real-world problems. In IFEVL, a benchmark for how well a model follows instructions, it scores over 91%, nearly matching GPT-4o. Toxygen, which tests whether a model can detect and avoid toxic content, shows 5-4 doing surprisingly well, ahead of some much larger models. And perhaps most stunning, in FlenQA, a benchmark for factual question answering, it scores 97.9%, outperforming almost everything else on the chart. These results paint a clear picture. 5-4 is not just a clever toy, it's a serious contender in real-world use cases. Now here's where it gets even more interesting. These models are optimized for local inference. That means no API calls, no external servers. You can run them on your laptop or even your smartphone, using technologies like ONNX or GGUF plus llama.cpp. This is a game changer for several reasons. Privacy. Your data stays with you. Speed. No latency from cloud requests. Control. Customize your model, fine-tune it, even modify it for niche tasks. Imagine AI-powered note-takers, search agents, research assistants, or code companions, all running entirely offline. For edge devices, developing countries, or privacy-sensitive industries like healthcare, this opens a world of possibilities. The trend is clear. Smaller, optimized models are no longer just good enough. They're beating the giants at their own game, especially in reasoning. This also hints at where the future of AI is headed. Efficiency-first architecture, smarter data curation, real-world deployability. It's not just about having the biggest model anymore. It's about having the right model, trained the right way, for the right task. So, what do you think? Can small models truly replace giants like GPT-4 in day-to-day tasks? Will local AI become the new standard? Let me know in the comments. I read everyone. And if you found this analysis helpful, please like, subscribe, and share it with someone who's into AI as much as we are. We're just scratching the surface of what 5-4 can do. So stay tuned. More benchmarks, deep dives, and AI updates are coming your way. Right here with me, Francis. What if your next home assistant didn't wait for a Wi-Fi signal to work? What if it didn't rely on a single central brain, but instead had 100 tiny minds scattered across its fingers, arms, even skin? This isn't science fiction. It's PI00.5, a revolutionary new robot from a startup called Physical Intelligence. And it might just be the first machine that actually feels like it's thinking. For decades, robots have amazed us, from dancing robots on stage to warehouse bots packing groceries at lightning speed. But there's always been a catch. Most of these machines are trained for one task, in one environment. Move them to a different room or give them a new job, and they break. Why? Because they rely on a big centralized brain. Every camera, every finger, every joint sends signals back to a single processor, which then decides what to do. This model is powerful, but slow, rigid, and fragile, especially when robots are placed in messy, unpredictable environments like your kitchen. PI 0.5 changes that completely. It spreads the brain, literally, across the entire body. Imagine a Lego-style architecture where each part of the robot, a fingertip, an elbow, even a soft rubber pad, contains its own microbrain. These are called Pi nodes. Each one has its own sensor system, actuator, and neural network, meaning it can make local decisions in real time. If a finger starts to slip on a wet dish, it adjusts its grip instantly, without waiting for a central server to respond. That's what makes it so powerful. Reaction time under 10 milliseconds, 25% lower energy usage, and movement that feels smoother and more natural than anything we've seen before. You could say, this robot has a nervous system. Now, fast reflexes are amazing, but they're not enough. To actually be useful in a home, a robot has to understand language, vision, and context. That's where the second layer of PI 0.5 comes in. A massive Vision Language Action Model, or VLA. This brain was trained on more than 400 hours of footage, not just in labs, but in real homes. Messy apartments, bad lighting, noisy backgrounds, robots knocking over chairs and learning from it. And it didn't stop there. They added tons of captioned images, verbal instruction recordings, and demonstrations from both humans and other robots. The result? PI 0.5 understands commands like, pick up the red mug carefully, or even, clean the bedroom. And it knows how to break that down into steps, navigate to the mess, pick up objects, sort them by type, wipe down surfaces, all without ever seeing your apartment before. In tests, PI 0.5 performed cleaning tasks in totally unfamiliar homes, without pre-mapping, without markers, and without cloud computing. It completed 94% of its tasks successfully. When trained only on internet photos, performance dropped. When they removed robot-on-robot demos, it plummeted. The lesson? General intelligence in robots doesn't come from perfect data. It comes from diverse data. That's why this robot was tested folding laundry, making beds, scrubbing sticky stains, and even reacting when someone bumped into it. And no, it didn't freeze or panic. It adjusted and kept going. For years, we've had robots that can do cool tricks, backflips, dance routines, industrial sorting, but they've always been fragile outside their narrow domain. PI 0.5 breaks that mold. By combining local, reflexive intelligence with a powerful, data-rich brain, it's more like a living organism than a computer on wheels. And that's what's so exciting. It's not just about smarter robots, it's about practical robots. Ones that can help elderly parents live independently, assist in hospitals, or just help you clean up after a long day. And thanks to its low-power, decentralized design, it's affordable to scale, not a luxury toy for billionaires. Of course, it's not perfect. PI 0.5 still drops things. Sometimes it grabs the wrong object or takes an awkward path, but it's learning, and more importantly, it's learning like us, through trial and error, through experience. So here's the question. Would you let a robot like PI 0.5 fold your laundry, do your dishes, clean your kitchen? Let me know in the comments. And if you enjoyed this look into the future of robotics, give this video a like, subscribe for more AI news and deep dives, and share this with someone who still thinks robots are just toys, because the future is knocking, and it has 100 brains. OpenAI's O3 model was hailed as a groundbreaking achievement, a glimpse into the future of artificial general intelligence. Early benchmarks stunned the world. We thought we were standing at the gates of AGI. But today, new evidence paints a very different picture. A hidden story of unexpected limitations, surging costs, and the hard truth behind the O3 hype. What really happened? And what does it mean for the future of AI? Stay tuned. The answers might surprise you. Welcome back to the channel where we dive deep into the world of AI breakthroughs, explaining the complex in simple and clear language. Today, we're looking at one of the biggest shifts in the AI narrative so far this year, the rise and reevaluation of OpenAI's O3 model. When O3 first appeared, it dominated the ARC-AGI leaderboard. It was heralded as a major leap toward artificial general intelligence, or AGI. OpenAI itself was confident enough to label it internally as a milestone. But as researchers dug deeper, they discovered that O3's true capabilities were not as impressive as they first appeared. When the ARC-AGI benchmark results were first released, O3 stood tall, achieving scores that hinted at human-like reasoning. A new era seemed within reach. But the ARC-AGI test isn't just about getting right answers. It's about demonstrating real, flexible, adaptive intelligence. And that's where the cracks began to show. As new experiments rolled out, using both low and high levels of reasoning, the real performance gaps became undeniable. Let's dive into the data. At medium reasoning levels, O3 performed decently, better than many previous models. However, when pushed to high reasoning demands, its performance dropped significantly. Even more troubling, the cost of generating responses skyrocketed. At high reasoning settings, O3 consumed massive amounts of tokens per task, sometimes 10 times more than at medium settings, without delivering proportionally better answers. In many cases, increasing reasoning level only made the model more verbose, not more accurate. Take a closer look at this graph. Here you can see the number of tokens used for each task. Notice the clear clusters. Some tasks performed well at medium reasoning, but failed entirely at high reasoning. This suggests that O3's supposed deep thinking was often just token inflation. More words, higher cost, but not necessarily deeper understanding. And remember, in real-world applications like coding, summarization, or problem-solving, efficiency matters as much as raw capability. Meanwhile, another model quietly entered the scene, O4 Mini. With far fewer parameters and far lower operational costs, O4 Mini achieved comparable, and sometimes superior, results on key reasoning tasks at a fraction of the price. This forces us to rethink a basic assumption. Bigger models aren't automatically better. So, what does all this mean for the dream of AGI? It means that achieving true general intelligence isn't just a matter of scaling up. It's not about throwing more parameters, more compute, and more tokens at the problem. It's about building models that reason efficiently, adapt quickly, and understand deeply. Today, the road to AGI looks a little longer, a little more uncertain, but also perhaps a little clearer. So, what's your take? Is AGI still within reach in the next few years? Or are we only at the beginning of a much longer journey? I'd love to hear your thoughts. Drop a comment below. Let's start a conversation. And if you found this breakdown helpful, don't forget to like, subscribe, and hit the notification bell to stay ahead of the curve in the rapidly evolving world of AI. Thanks for watching, and until next time, stay curious. Imagine a future where accessing powerful AI doesn't cost a fortune. Imagine beating OpenAI's GPT models for half the price. That future isn't years away. It's happening right now, thanks to Baidu's new Ernie models. Stick around because today, we're diving into a major shakeup in the AI world and what it means for you. Hey everyone, welcome back to the channel. I'm Francis. If you've been following AI developments lately, you know the race is heating up. With OpenAI dropping GPT-4o, DeepSeek pushing boundaries, and now Baidu stepping onto the global stage with two massive announcements. Today, we're going beyond the headlines. We'll break down Baidu's two new models, the Ernie 4.5 Turbo and Ernie X1 Turbo, and we'll explore why their ultra-low pricing strategy might just change the game. Baidu isn't a startup. They're often called the Google of China, leading innovations in search engines, autonomous driving, and now artificial intelligence. They've been working on their Ernie series of models for years, but with Ernie 4.5 Turbo and X1 Turbo, they're clearly signaling their ambition to compete globally. And not just compete, but dominate, by making AI accessible to businesses and developers everywhere. So let's start with Ernie 4.5 Turbo. According to Baidu, this model offers comparable, if not superior, performance to OpenAI's GPT-4 Turbo. It specializes in a range of tasks, from generating human-like text to deep question answering to professional-level coding support. Here's a visual breakdown. You can see how Ernie 4.5 Turbo scores in major benchmark tests, closely matching or even exceeding GPT-4o and DeepSeek v2.5 models in some areas. This isn't just marketing talk. Early user reports confirm smoother reasoning capabilities, faster response times, and better handling of complex instructions. Plus, Baidu claims they've significantly improved the model's alignment, meaning fewer hallucinations and more reliable outputs. But Baidu didn't stop with one model. Enter Ernie X1 Turbo, a model specifically crafted for enterprise-grade tasks. Unlike Ernie 4.5 Turbo, X1 Turbo isn't limited to text. It's multimodal, capable of processing text, images, and even short videos. Take a look at this chart. It shows how Ernie X1 Turbo measures up against some of the most advanced enterprise models like DeepSeek's X and OpenAI's O1. X1 Turbo shines particularly in handling multimodal data. Think customer support bots that understand screenshots or research assistants that can interpret graphs and diagrams. Baidu's vision here is clear: to become the one-stop AI provider for businesses around the world. Now let's talk numbers, and this is where things get really interesting. Ernie 4.5 Turbo is priced at just 1.4 per million tokens, compared to GPT-4 Turbo's typical $3 per million tokens. And Ernie X1 Turbo, even lower, just 0.6 per million tokens. Let that sink in. For less than half the cost, you're getting competitive, sometimes better, performance. This is a classic market disruption strategy. Lower the barrier to entry, flood the ecosystem, build loyalty before competitors can react. It's aggressive, it's risky, but if it works, it could flip the global AI market upside down. Of course, great models are just part of the story. Baidu also unveiled 2 new platforms alongside the Ernie launch: Xinxiang, an AI agent platform allowing users to automate complex workflows using natural language instructions, and Hiboxing, an avatar generation service that can create realistic digital humans for marketing, education, and entertainment. These tools show Baidu's larger ambition, not just to sell models, but to build a complete AI ecosystem, a direct competitor to OpenAI's API platform, Anthropic's Claude, and Google's Gemini environment. So what does all this mean for the future of AI? If Baidu's models perform as promised, and if they maintain this pricing advantage, we could see massive adoption across industries that previously found AI too expensive. Small businesses, startups, educational institutions, suddenly the playing field would be much more level. And this could push Western companies to accelerate development, lower their prices, or offer more flexible plans. In short, competition is good for everyone. But and this is a big but, Baidu isn't guaranteed success. First, there's the issue of trust. Many Western companies remain cautious about using Chinese-developed AI, especially when sensitive data is involved. Second, while Baidu's models are strong in Chinese, it's less clear how they perform across English, Spanish, French, and other major global languages. And finally, scaling internationally, supporting developers, ensuring uptime, preventing bias, those aren't easy tasks. So while Baidu's announcement is exciting, the real test will be adoption outside of China. Still, regardless of the challenges, Baidu has fired a shot across the bow. Their Ernie 4.5 Turbo and X1 Turbo models are serious entries into the global AI arms race. As consumers, developers, and businesses, we all stand to benefit from this growing competition. The era of affordable, high-performance AI is closer than ever. So, what's your take? Would you trust a Baidu model over OpenAI or DeepSeek? Let's get a discussion going in the comments below. And if you enjoyed this deep dive, make sure to like, subscribe, and smash that notification bell, because there's a lot more AI news coming your way. Thanks for watching, and I'll see you in the next one.